How are you? My name's Joanne. So the question you have stated that you have 2,344.44 grams of water that react according to the balanced chemical equation, and what is the theoretical yield of H3PO4? So according to your equation, which is balanced, your water to phosphoric acid ratio is a 6 to 4 mole ratio. Now, this particular question asked you what your theoretical yield was. Didn't specify a unit, but it could be moles, it could be grams. When I solve these or I give these to my students, I'm typically requesting for grams as a theoretical yield because that is what would be measured in a laboratory environment. You were given grams to start. So you were given grams, and we're going to infer that you are going to need to give your answer in grams. The connection between water and phosphoric acid is in moles. That's what the 6 and the 4 coefficients represent. So I put down a little bit of work, and I'm going to try to take you through what I did. I'm also going to attempt to paste this into the answer response as well on Ask an Expert. So here, under the text editor, I typed up how to do these answers, how to do this work. And there's actually 2 different methods which you could tackle this. What you need to understand, though, is that you need to have conversion factors to do this. You need to be able to convert grams of water to moles of water, and then you need to be able to convert moles of phosphoric acid to grams of phosphoric acid. The connection between water and phosphoric acid are the coefficients in the balanced equation, which are moles. So, using dimensional analysis, all right, so we're going to be using dimensional analysis, and I am going to try to rewrite this for you on board. You need to keep in mind certain conversion factors. So I'm going to go back to the whiteboard here. And these are the conversion factors that you need to be aware of. In this entire problem, we are going from grams of water to moles of water, and then from moles of water to moles of phosphoric acid, and then from moles of phosphoric acid to grams of phosphoric acid. So I need 3 conversion factors. Grams of water to moles of water. So my conversion factor should be 18 grams is equal to 1 mole of water. My moles of water to moles of phosphoric acid should be the coefficients. 6 moles of water is equal to 4 moles of phosphoric acid. Then I would like to convert my final answer, which will be left in moles if I stop there, into grams. So moles of phosphoric acid converted into grams, I'm going to use the formula mass of phosphoric acid, which I calculated to be 98 grams. 3 hydrogens, which is a total of mass of 3, 1 phosphorus, which is a mass of 31, and 4 oxygens, which has a total mass of 64, all add up together to 98 grams. So 1 mole of phosphoric acid has a mass of 98 grams. Now, I rounded all of my masses to whole numbers. Your instructor might want you to be a little bit more specific with masses and maybe go to the tenths or the hundredths. So you will have to adjust for whatever your teacher, instructor, or professor is asking for. So moving on, if we are going to start with this using dimensional analysis, we are going to want to put our given amount that we are starting with, which is grams of water, over 1. So we have 2,344.44 grams of water. And that's going to be over 1. Now, we want to eventually cancel out grams of water and end up eventually with grams of phosphoric acid. So my 3 conversion factors, I'm going to turn into 3 fractions. Now I can set up a conversion factor as a fraction because technically they're equal values. So 18 grams of water is the same value as 1 mole of water. It's the same as saying 4 over 4. That's equal to 1. Or 2 squared over 4. That's 4 over 4, which is equal to 1. All these conversion factors, I'm actually not manipulating quantities. I'm manipulating units and relationships between different units. So when it comes down to this, I started with grams of water and I want to cancel out grams of water. Well, the conversion factor that I have, which indicates grams of water, is here. So 18 grams of water is equal to 1 mole of water. I want to cancel out grams. So grams right now is on top, and I'm going to put that as a denominator. So my 18 grams of water is equal to 1 mole of water. What that's going to do is it's going to cancel out my grams of water. That's a bad color. So now right now I am left with moles of water. I don't want moles of water. I want to eventually get to phosphoric acid. So I'm going to look at my conversion factors and I'm going to see that I have a relationship between moles of water and moles of phosphoric acid right there. Since my moles of water is on top in my previous conversion factor in the numerator position, I would like moles of water in the denominator position so I can cancel out that unit because I don't want that unit in my answer. So I'm going to put down 6 moles of water as the denominator and 4 moles of phosphoric acid as the numerator. What that's going to do is allow me to cancel out my moles of water. And now I'm left with moles of phosphoric acid. If your instructor is asking you to just find the theoretical yield in moles of phosphoric acid, this is where you would stop. I, on the other hand, would ask that you find it in grams because if you were to do an experiment, you would be measuring your resulting product in grams. So the last conversion is to turn moles of phosphoric acid into grams of phosphoric acid. My last conversion factor is right here. 1 mole of phosphoric acid is equal to 98 grams of phosphoric acid. So I'm going to place the 1 mole of phosphoric acid as a denominator to cancel out with the 4 moles of phosphoric acid unit in the previous conversion factor. 1 mole of phosphoric acid is equal to 98 grams of phosphoric acid. So when it comes down to canceling out, all my units except for grams of phosphoric acid is canceled out. So the math that is involved is I'm going to do 2,344.44 times 1 times 4 times 98 divided by the product of 18 times 6. And what I will get eventually, pardon me for one moment, using this method, I'm going to get 8,509.45 grams of phosphoric acid. So make this a little smaller so it fits on the page. All right, so to fit on the page, that was supposed to say 8,509.45 grams, and I'm just going to type in phosphoric acid, H3PO4. And this platform is a little limited in terms of subscripts, so I apologize for that all the numbers are the same size as the symbols. So that is one way to solve this using dimensional analysis. The other way that you can do this is you can literally do it step by step. First, convert grams of water into moles of water and come up with that value. Then convert moles of water into moles of phosphoric acid using a mole-to-mole ratio. Then convert your moles of phosphoric acid into grams of phosphoric acid using a mole conversion. Dimensional analysis just takes that through in one setup, whereas you could list this in 3 different steps using it by a step-by-step method. Both methods, when I did it, came out to approximately the same answer with a difference of plus or minus 1/100th of a gram. And that was mainly due to rounding and conserving significant figures. I hope this helped. I apologize for the handwriting with a touchscreen, but if you have any further questions, I'm available for online tutoring. Thank you. Bye.